Okay, Hamza, and I'm going to be taking you through uh, a project briefly through which is near field communication-based blockchain authentication for securing land property management in constrained resource settings. As you can see, these are my group mates, Alan, Ibrahim, and Trevor, and our supervisor is Galewango Mavi. Um, so I'm going to be taking you through the introduction, the related work problem statement, our research objectives, the research contributions, and the methodology briefly. So, in a brief introduction is the study aims to develop a blockchain-based property management system for Uganda, integrating blockchain, machine learning, NFC, and OCR to improve land title security and transparency. This is because Uganda faces challenges in land ownership, including unregistered tenure systems, fraud, and disputes worsened by inefficient record keeping. This occurs because of the mutable ledger, the ways or the land titles are actually stored. So we aim to use blockchain and other technologies like NFC and OCR. So as you can see here, through the leading newspapers in Uganda, there is Monitor and New Vision. One is actually trying to is putting out an advert for registrations of titles, and then another is talking about how much land wrangles are a major problem in Uganda. So these are the related works. We can see there is land registry in Ghana, blockchain. The blockchain, we also have secure property management systems. Then NFC, we have on-site land title verification, what we're going to use it for. Then OCR, digitization of historical land records, and AI, automated title verification. And then the particular integrated framework, combination of blockchain, OCR, AI, and NFC for land management systems. So our problem statement uh, goes as follows: as land management in Uganda faces significant inefficiencies due to lack of secure and transparent, reliable systems. So we ledger a blockchain-based property management system for Uganda to which is an immutable ledger to record property data while ensuring it accommodates updates. So we all opt to use OCR and machine learning and NFC, whereby OCR is used to digitize physical records, and then NFC is for, as we talked about in the last slide, it's for on-site land title verification, and AI for automated title verifications. Our research objectives are to develop a blockchain-based ledger system, to design and implement an NFC-enabled system for real-time on-site verification, to derive and evaluate key performance metrics for the blockchain and NFC-based system, to utilize optical character recognition for digitizing and analyzing legacy land records. So the research contributions, we were able to develop a blockchain-based ledger, uh, which introduces secure, transparent, and tamper-proof ledger to address Uganda's unique property management challenges. Then we're able to integrate AI-powered OCR and utilize NFC technology. Um, as you can see here, this is our methodology, which talks about a user and the particular interface we've developed. Then this user interface, there is data acquisition. There is one, the user can actually upload a land title, and then we do data verification using the NFC and validity of the data. We use OCR and electronic or to scan to create electronic documents. Then this data is encrypted and it's deployed through a smart contract to the blockchain and then stored in our particular wallet address database. So the key technologies we're using NFC, OCR, and blockchain. From my colleague will take on from there.
Hello everyone, this is Kalem Alan and I'm going to explain I'm going to explain the RAG intelligent extraction. So this RAG is retrieval augmented generation, and this was done to intelligently extract data out of the different land titles. It was done so because there are different data qualities. For instance, quality of PDFs and quality of images for the legacy data, and the data is the land title. So these are the following steps that we go through generally. We had the uploading of the document, and we also have reading it, running it through OCR to retrieve the text, and running the text into an embeddings vector. Running the text to the model while retrieving the context from the embedding vector and passing it through to the large language model for it to get the sanitized data output. So the input was done through the system. PYMU PDF reader is a library that is used to read PDFs and images and images in Python, and it reads the image into it reads the input into the system. Run it through our OCR functionality that retrieves the text out of this. So this text is, we need a context out of the text. That's why we go through, we use a library like sentence transformer to run through to retrieve a context out of it. So when this context is retrieved, the vector it's compared with one in the vector embeddings that were stored, and this context is passed to the language model. The context, these vector embeddings, how they were gotten, the model was trained onto the land titles we had, and we were able to retrieve the different contexts in it. The context might include the different the properties of the dataset. So the model, once we feed this into the model, it knows what it's supposed to retrieve, and it returns a sanitized data output that has been mapped to be fed into the database. And and also uploading the titles to the chain. So these verified land titles have to be uploaded to the chain. And the process of doing that is it involves three steps. First of all, the title has to be verified. And second, we have an IPFS system. This system is used to store data that is later stored onto the chain. So once this data is fed into the IPFS system, we have an online IPFS system that we work with. You upload it to a node, and this node can be anywhere. It's decentralized, and it will return a content identifier, a CID. And this CID can be used to locate that information that has been uploaded to the IPFS system. This CID is fed back, it's is fed into the chain using smart contracts, and the blockchain the blockchain the blockchain we're using is Superior Ethereum, which the testnet. So we upload this to the chain using smart contracts, and once it's uploaded, we get a notification. We get a notification. So this system, and being referencing it, reading from the chain, the CID is read of it, is the CID is read from the chain, and this CID is used to locate the title, which is a media, and will be retrieved from the nodes back to the system, and you're able to read the title. Yes. So the methodology for transferring land ownership into the system. Remember, the system has different points that have to be touched when doing an action. So for transferring one, both users have to be on the system, and the title has to be verified. So the seller initiates a transaction. That is by activating a transaction to who and under what measures. So the referees and the witnesses, we would have the government officials who would have to proofread everything that is being done under that transaction to see if they are valid, whether the right person is transferring the land. So once that is done, then we'll go to the system, the verification bit of the system. Verification, we are working with NFC cards where the buyer's NFC and the seller's NFC have to be fed onto the system. These NFC contain wallet addresses, blockchain wallet addresses, which are unique to every user. So when they are fed, the system will be prompted to transfer to make using a contract to make a new transaction that shows that land A has been pushed to user B, and this is the new wallet address. So once that is done, a transaction is approved. When it's approved, we move to sorry, when it's approved, that the title is read onto the chain, and two users are notified that the seller has transferred this amount of this title to the buyer. Yes. This is the land title that we. This is the Ugandan Land Title Act, one of the types of the titles, and it shows you the different properties that it has that we have to extract from. So for our model development, we came up with data set, and this is the description. It contained 1,000 images, 500 for the face and 500 for the back. And this data set was designed for applications in land management, like geospatial analysis, since it had plot distributions within it and AI-based land verification, and that is the RAG-based extraction and sanitization. So the entry of the asset consisted of Ugandan land documents with metadata such as the name, the land size, the title, and the location. Corresponding plot division was made, showing randomized land division in specified region, bounding boxes and plots to facilitate and allocation analysis. So the process of generation included randomly generating title numbers, landowners. We fed off. We got a valid titles, and we replicated them using the same format. So the location were drawn to the districts, sub-counties, and villages in Uganda. The plot layout generation for a base land image is used. Randomized rows and columns 3 to 10 and 2 to 6 for unique plot divisions. And the sample of the titles that were generated or images that were generated is as follows. Where this side you're seeing the plots, the QR code that contains the information that is the transaction ID, then the land title number and the location. And on your right, you can see there is a title register, sorry, a title a registration title act where it shows the name of the owner and extra information about the title. So this dataset we did EDA on the dataset, and we were trying to understand these generated images, and this is what we got. They had for the layout and the details for all the images, and this table shows the width, the standard deviation, the heights of the images, the mean and the sizes of the images. As we can see for the layouts, the mean size was 201 kbs for each image, and for details 86.440. And the distribution of images, we said 500 each, and this is what you see here. And also for the scatter plot showing the height division with no clear diagonal pattern by slightly scattered distribution. Yes, thank you very much. Let me call upon my next to proceed from there.